So let's begin. So this was our syllabus. We reached till here. So today we are going to discuss about this project, computer-based data monitoring and device control. We already learned about arrays and few other uh, things related to C, like variables, functions, control statements. Mostly all the basic concept we discussed already. So we will finish this project. With that, with this project's help, we are completing the beginner's step. So from next project onwards, we will be dealing the topics which lies down under the intermediate class. Okay, so let's start. So this is our project name. So I created one folder for that project, computer-based data monitoring and device control. Inside that I have a block diagram of our project. As usual, we have PIC16F877A Microcontroller as the center programming unit or CPU. Uh, we have two sensor here. One is temperature sensor and light intensity sensor, basically an LDR. So both are analog type. So these two sensors are connected to ADC. Okay, so the remaining stuff, we have a computer which can interact with our microcontroller via UART. We already learned about UART in our previous session. UART will help you to communicate with the serial devices. So here serial device is our computer. Okay, so computer will have a software, a GUI kind of software, graphical user interface, where you can see the temperature and light values. It will update periodically with the help of PIC16F877A microcontroller. What it will do is it will read the temperature, light value, and it will send it through UART to our computer. This computer can be either Mac or Linux or Windows operating system based computer. You can use any of them. And we have few relays which can be controlled via this GUI. So GUI will have some, right now I don't have the GUI ready. I will show you how a GUI looks like. So I am opening Paint. So in GUI we can make with the help of different software. With the help of Python you can make GUI. There are few other softwares available for GUI creation like Qt, um, Visual Studio, Visual Basic and C Sharp. With the help of C also you can create with the graphics.h file. That is bit complex, but yeah, we can create. So LabVIEW also there. So our GUI we can tell like this. So here there would be an area where temperature will be displaying like this. It will display temperature 98 degrees Celsius kind of stuff. Also we have our light intensity monitoring area where you will see the light intensity value, which should be calibrated. I am putting some rough value based on the ADC value. ADC value you can see 512, something like that. Also you can see few buttons over there to control relays. So if you press the button, If you press the button, relay will turn on and turn off. So this is the GUI kind of stuff. Here in this project, we will be dealing with the microcontroller interrupt also, how we can program serial port interrupt, how we can write code for serial port interrupt. We will be discussing these stuffs today. So let's create one more folder over here. Software. Also, we need a folder called hardware. Opening our simulation software. We can draw our hardware quickly. Let's take microcontroller PIC16F877A. Okay. We need LM35 temperature sensor. If you understand the basic concept of ADC related to our microcontroller PIC16F877A microcontroller, you can interface any kind of analog devices to our microcontroller. Yeah, you can always watch previous videos to get refreshed about the topics which we already discussed. Now we need LDR. LDR need biasing. For that I am taking resistance. So whenever there is a light intensity variation, corresponding voltage variation will happen here. For that we need to provide a supply here as well. I am keeping 5 volt over here, grounding the other end. You can see the voltage variation. I will show you later. So let's connect the remaining part. We need our computer, right? So computer here I am representing with the help of virtual terminal. I am connecting the TX pin with RX pin of the virtual terminal and TX to RX pin of the microcontroller. It's done. Now we need few relay. You already know relay can't be controlled directly with the microcontroller. So in between I am keeping few transistors. PC107, is that available? Yes. I will take 2, as I am planning only having 2 relays. You can have multiple always. Based on the pin amount of pin available on your microcontroller, you can decide how many relays you want, how many sensors you want, all depend upon the pin availability. connecting ground over there. So here transistor acts as a switch. Both the relay coils, one end is connected to 12 volt. I already explained the working of relay last class, last session. Please watch those videos if you want to know that. Okay, so here 12 volt is connected to the coil, and BC107 will take care of that. Hello Paudan, good morning. Hello. Yeah, I already started explaining here. It was recording. So this is our last project in beginner stage. It's a computer-based data monitoring and device control. So the thing is that we will have these kind of sensors, temperature sensor, light sensor. It will, okay, wait, I will share that. Okay. Okay, so I was talking about this. So uh, here we have two sensors, okay, temperature sensors, temperature sensor and light sensor. And we will update the value of temperature sensor and light sensor to our computer PC. Okay, so there would be a GUI. GUI would be looking like this. We need to create such kind of GUI also with the help of some other software, LabVIEW, Python or something like that. So there you can see the temperature and light sensor values. Also you will have few switches over there in the GUI, graphical user interface. There you can press it to turn on the relays. So we have relays over here. So if you want to control the relays using your computer, you can use this setup. Okay. So I was drawing the circuit of that. So it's completed. So the sensor, temperature sensor is connected at ADC pin of microcontroller. Also the LDR is connected like that. We have two relays over here and a computer interface. So this is a collection. What I can say, this is a project which we can make with the help of our previous knowledge. We already learned how to interface ADC. Also, we know how to control GPIO, general purpose input output. Also, we know how to make use of UART. Um, Previously, we did all these steps. Now, we are going to combine all those ideas to make this project working. Yeah, I already have few folders over here in this particular project, computer-based monitoring device control, hardware and software. Inside that hardware, I will save this circuit diagram. Okay. Now what we need is our MPLAB ID. I'm opening that MPLAB X ID. In this project we will be doing initially most of the things we will copy paste from the previous project, previous code. After that we will modify it for the current requirement. So this is our previous project. Now we need a new project over here. File, new project, microchip embedded application. Next, we need to provide microcontroller part number here 77A. Just take simulator. Next, compiler, you can choose this one, XC8. Next. So they are asking for the project name, computer-based data monitoring and device control. Okay, project location, just up, computer-based data monitoring and device control software. Finish. What you have to do is should be aware that we have two projects over here. Okay, in this project tab you can see two projects. This is our previous project and this is our current project. Okay, so what we have to do is we need a main.c under the source file, right click, new main.c. So here I will remove this new main. Instead of that I will keep main only, main.c. And it is going to save under this folder. Yeah, this is what we needed exactly. Yeah, so hit finish. It will create a main.c over here and it will load the base template also. What you can do is just go to the previous project and go to source file, main.c. From there you can copy paste few things. You should know what and all. We need serial communication. So also we will be using delays. So you can copy this delay function, just go and paste over here, delay. Then you need a function, yeah, send it to PC. If you want to send some characters, yeah, we need to send characters like our temperature, light sensor value, some other parameters. If we want, we need this function, send it to PC. I explained how this particular function works in our previous video. We can watch if you want a reference. Send it to PC. Next, read keyboard is not necessary. These are not necessary. This is necessary because we are going to use serial communication. These these commands or this initialization of the registers is necessary if we are communicating with the um, other devices via UART. So this is a UART initialization statement. I'm copying that also, keeping it under main. Now I need few things related to ADC, which is also already available. Let's see, file. We have automatic temperature controller project here, software. Just I am opening that also. Go to source file in.c. Yeah, here I have this read ADC function. I'm taking that too. So I opened three project over here. Okay, don't get confused. So what we are doing now is copying the previously created codes from uh, other projects and putting it over the new project here. Okay, so read ADC. So this is our new code, new main.c. Copy, paste. Yeah, done. Read ADC. So here it is showing some error as printf. So sprintf needs a header file called hash include, I think string.h. Let's check. Sorry, stdio.h is that. stdio.h. Yeah. Just save it. Yeah, error got vanished. So we have ADC related stuff over here and its initialization. Okay. So what we missed is we initialized the UART. That's done. Now ADC related initialization we need. Temporarily I will copy this initialization, but we have to check few parameters because in our previous ADC project we just used single channel ADC. Now we have two analog signals here at channel 0 and channel 1. So we need to make sure that we are properly configuring that two channels. So this is the two registers which we need to take care while reading that. And we will also modify this read ADC. Okay. So initialization of ADC is partially done, and complete initialization of UART is also done. Now we need to initialize our GPIO. For that, just go back to the circuit diagram. We will consider the relay part first. Before that, we need to tell something over here, that is hash define relay 1, hash define relay 1, which is at RD0. Hash define relay 2 is RD1, RD0 and RD1. So that is done. Now we need to tell the status of that pins. Hash hash define on means you know how to make it on, right? So by making 1 over here, this will in turn make this transistor on, that will in turn make a current through this transistor. So by making 1 over here, it will turn on. So on means 1. Now hash define off means obviously 0. Yeah, done. Now we will go to initialization of port A. We will begin from here. Okay, port A will open data sheet. So this is PIC data sheet. We'll go to analog to digital converter module. As you already know that port A is going to be port A is handling the analog pins. We need to initialize that pin first. Tris A equal to which all pins are going to be input, RI0 and RI1. So we need to make 0x, both the spin will be high. So it is 3, right? Digital 0x03. If you are doubtful, go to calculator. Take binary. What I said is these two pins are input. So this will be 1 and this will be 1. Go to calculator, put 2 ones over there, find out which is the hexadecimal value coming, just put it over here, keep one semicolon also. Also we need to initialize the corresponding port register that we can keep 0. Port A. Now that is complete. Now we can go to port C because we are not using other ports. Port C, RC6 and RC7. Port tris C equal to 0x C0 port C is also equal to 0x C0. Why? Because if you go to, we already discussed this fact, I'm just updating. If you go to port C, see here you can see that bit SPN and bits tris C7 and 6 have to be set in order to configure pins RC6 and RC7 as USART. Okay, so this is the thing which they already mentioned in the datasheet, that we have to make these two pins input. So that is the reason why I kept these two pins input. So you can see if you are keeping 1 1 here, 1 1 0 0, go to calculator, 1 1 0 0 will give you C. That is how we got C over here. Okay, C0. Upper nibble is C, lower nibble is 0. Now we will talk about port D, where relays are like port D equal to 0x00 because relay is an output device, so we need to keep it 0. Okay, sorry. Before that, we need to initialize the trisD register. Okay, port D is needed, but we need to initialize tris first. TrisD equal to 0x00. Port D equal to this value. Why port D equal to 00? If you are keeping some other value like 1 or something at this position, it will in turn make these relays on. So we need to ensure that at the time of microcontroller power on or the initialization stage, these pins should be low in order to make these relays off. So that's the reason why I kept port D equal to 0. Now ADC initialization. The fact we need to check related to ADC is that I will tell you when multiple sensors are coming to ADC. So these are the registers which affect channels. Okay. So these are the channel selection pins which we need to consider while calling this function read ADC. So the channel selection we need to update. So in this particular code, channel channel selection is done over here only, ADCON 0 and ADCON 1. It is permanently set it to 0. Permanently set it to 0 means it will take channel 0 by default. Always channel 0 will be getting converted. Uh, but in current project we need to use channel 0 as well as channel 1. So we need to um, write a code which handles these registers as we required. So let's go to the other register ADCON 0 and we have one more register ADCON 1. In that ADCON 1 register we have few registers which helps us to configure our ADC pins. So if you keep all these registers 0, we are going to get all the analog pins starting from AN0 to AN7 as analog. Here we need only two pins, AN0 and AN1. You can always come and see. See, this is AN0, this is AN1. AN0 belongs to temperature sensor, AN1 belongs to LDR. So what I am going to do is we need to make sure that these two pins are in analog mode. Okay, you can make I'm trying to recall your memory, make recall of your memory. So what I told in a previous session is that by configuring these registers we can always control how this microcontroller port A can behave. It can behave either as a general purpose input output pin which can handle 0 and 1. Also it can be configured as an analog to digital converter which can handle values between 0 volt and 5 volt. Okay, now our need is to configure these two pins as input. So for that I am checking this table where we can find a value which can be loaded in order to get only that two pins become analog. I can see one over here, but it will make AN2 and AN3 as the reference. I can't take that. this I can take if I want, or else I can make 0 because uh, see, AN0, AN1, AN2, AN3, AN4, AN5, AN6, AN7. I'm not going to use the remaining pins, so it won't make any issue while the program execution because all other pins are not using. So I can write 0 over here. These all value I can keep 0 if I want, but I would like to keep, yeah, we can keep that only, yeah, 0. Then we will make all the registers, all the flags, all the lower nibble flags with 0. So AD-con1 will be, so what is the current AD-con 1? It is 80 only. Yeah, we can keep this value 80. 80 means 1 0 0 0 and remaining bits are 0. It will make all the analog pins as analog only. AD-con 1 right now it is pointed to AD-con 0 right now it is pointed to channel 0 only. So we should have a mechanism which selects channel 0 and channel 1. For that, we will modify this function read ADC. So I will tell you an idea that we have already learned the function, right? So we will be calling this function read ADC. Suppose we want to read temperature. Okay. So what I will be doing like, so I will calling this function TEM. Okay, temperature equal to read ADC bracket 1. If I want to read light, I will be writing like this: light equal to read ADC. So here I will be calling read ADC 0 because channel 0 it is temperature sensor. Here I will be calling read ADC 1 because channel 1 belongs to light. Here the compiler has no idea what temperature and light is. So we should tell the compiler what temperature and light is. That is called variable declaration. We already studied that. So unsigned int temperature comma light. So we have two global variable temperature and light. We are using that for storing the temperature value and light intensity value. See how I am calling this function temperature equal to read ADC bracket 0. So why, while calling this function I am passing a value to that particular function. So that particular function should be capable of receiving that value. So I need to make some modification over here as well. So this is a function with an argument. So I am going to write a function with an argument. So this is an argument. unsigned int channel. So I am passing channel number. Okay. Mm, okay. So I am passing channel number. Channel 0 belongs to temperature. You know that, right? See, channel 0 belongs to temperature and channel 1 belongs to LDR, light. So here I am getting channel value. Now what I have to do is in this function, before starting the conversion, I need to tell the ADC which channel I am going to use. For that I will use this channel value. There we will use our conditional statement capability of C program. If you hit control space, you will get this suggestion. Just hit control space and choose that function and hit enter. If channel equal to 0, what we have to do is we need to do three things. For that, just keep bracket. We need to make CHS0, CHS1 and CHS2. We have three registers, CHS0, CHS1, CHS2. All three should be 0 in order to get channel 0. Okay, so what I am going to write is what is that? Yeah, CHS equal to 0, CHS1 equal to 0, CHS2 also, CHS2 equal to 0, semicolon. If you make all these CHS, what is the problem there? Okay, CHS0. I will keep it in a single line so that we can quickly relate it with the data sheet. CHS2, CHS1, CHS0, CHS2, CHS1, CHS0. So all these three are going to become 0 to get channel 0. Now if I am passing a value 1 over here, I should get channel 1 to get LDR. So that I need to make this value 1. This value means CHS0. CHS0 I have to make 1. Okay, done. Then it is a practice that after channel selection you need to provide a little time for the ADC to get the channel properly selected. For that I am putting a very minimal delay of maybe 2 millisecond time I will provide. A 2 millisecond delay, then I will tell the ADC to convert. So this if I can make else if channel equal to 0, this channel selection will be ready. Else if channel equal to 1, this channel selection uh, will execute and channel 1 will get selected for reading LDR value. So after that I am providing a delay. This information reading, providing a delay and all those things will you will get it if you read this data sheet completely. So they are telling that after channel selection you need to provide a bit of time in order to get the channel selection properly. So I think this read ADC function is almost ready. So yeah, now we will compile our code and we'll see. For that, I am removing the previous project. Without removing previous project, you can always do, but in order to avoid the confusion, I am deleting the previous project. Okay. Just remove option is there. Close option is there. Yeah. I'm just closing that. Okay. Now select our project. Just hit clean and build. So signing unsigned into incompatible type void. Temperature equal to read ADC 0. Okay. Yeah. So what I am trying to do is calling a function. After executing that function, I need to get a value this to this temperature. Okay. So here previously we updated our result directly uh, to this particular function. Here it got updated result function. So here what we will do is we will return the result. Okay. We will comment it out. These are the previous project code which we used to send it to UART. Now we have different plan. Okay. So we have the result ready after taking the result from ADRESH and shifting it left 8, shifting it left 8, and then concatenating it. Result equal to ADRESH, result equal to so we need to return this result. For that, just you have to type return result. It will return result. Just you can refresh your idea about function by watching our previous video where we discussed about function. So this function read ADC, at the end of the execution of the function it will return the result. So result will be either temperature or light intensity based on the channel selection. Okay. So result will be returned accordingly. For that, what is the type of result? Result is unsigned int. Okay. So you need to tell the compiler that this function will return a value of type unsigned int. So this function is will become like this: unsigned int read DC, unsigned int channel. So we are telling the compiler that this function will return a value of type unsigned it by putting like this. By putting like this, we are telling the compiler that this function is going to receive a value from from somewhere uh, from this code of type unsigned int. So this is what this left and right things mean. Okay. So I think now we can compile the code without an issue. There is one more issue. It is something related to make. Mm, First time I am seeing this problem. Can't create simple SDB file. So these are the forms where we can come and see when there is an issue related to compiler. I really don't understand what is the problem here. I'm just commenting all the stuffs inside this main routine. Still it is throwing error. I'm commenting all the remaining code also. But I'm completely clueless about this issue. I have to check. Maybe in next class I will come up with the solution for this issue. Actually, the code should compile because we are not seeing any warning from the compiler uh, during the coding, because usually we will get a notification right side, left side here, right? So that is not um, popping up. So I think there is no issue with the code. It is something with the settings related to compiler. I have to check that, and I will update you in the upcoming session about this issue.